Stars and planets, satellites, and many small asteroids are spherical, while the solar system, galaxies, and even black holes tend to be flat disks. For thousands of years, humans have been guessing the shape of our universe. Historically, religious texts answered this question in various ways. Jainism describes the universe as similar to the shape of the human body. It has a narrow top and widens in the middle and bottom. Ancient Israelites viewed the universe as a flat disk floating on water. The sky above, the underworld below. Philosopher Aristotle believed, our universe is a sphere, because the sphere is the most perfect shape. Hindu scriptures imagine the universe as a giant cosmic egg, containing everything inside. Scientists compare the actual mass of the universe to the critical density. It turns out there are 3 possible shapes. If the universe has a density less than the critical density, then there isn't enough matter to stop and counterbalance expansion. Our universe will expand forever. In this case, the universe is considered open or hyperbolic, saddle-shaped. If the universe's density is greater than the critical density, then the universe will eventually stop expanding. This makes our universe a closed universe, forming the shape of a 4-dimensional sphere. A 2019 study published in Nature Astronomy states, according to measurements of the cosmic microwave background radiation by the Planck satellite, there is a 99% probability that the universe is closed. The article suggests that the standard cosmological model is based on unknown physics, because no one has truly observed expansion, dark energy, or dark matter. We may need a completely different physics to understand the shape of our universe. The most widely accepted theory is that the actual density equals the critical density. The universe is flat like a sheet of paper, with infinite extent. This means the total density of the universe is about 5.9 protons per cubic meter, of which 4.6% is atomic mass, 24% is dark matter, 71% is dark energy. The end of the universe resembles a ripping apart scenario. All the matter is torn apart in a big rip. Also, when mentioning shape, scientists prefer topology. Objects in this case are malleable, so the universe can be shaped into many different forms. Some theories suggest its shape is like a ring, where the universe is flat, but connected at multiple points, with negative curvature. It can also be shaped like a trumpet, one end very wide, the other end very narrow. If so, people living at the narrow end would experience only 2 dimensions. So, what shape do you think the universe is? Please leave your thoughts. That's all for this episode. Please remember to like and share. Thanks for watching. See you next time. NASA's laboratory says we can use fungi to build habitats on other planets. But currently, this is only NASA's preliminary plan. However, they have already begun studying suitable fungi in the lab. This plan is called NIAC and is part of synthetic biology, which studies how to use life itself as technology. In the laboratory, NASA tries to manipulate a very special part of fungi, hyphae. The reason fungi can form various shapes is because of the hyphae, so we can specifically plan shape and size, guiding hyphae to get the fungi shape we want. Living on Mars or the Moon, the most important thing is the shelter. We need a shelter that can shield us from the sun, and one that can protect us from various types of radiation and harsh weather. If it can also supply oxygen, that would of course be even better. And mycelium can indeed provide oxygen through natural processes and the help of cyanobacteria. This special bacterium harnesses sunlight to reinforce its structure. At the same time, it can provide us with the oxygen we need. The outermost layer of our shelter will be made of frozen water. This icy water will serve as a radiation shield, and it will feed into a second layer of cyanobacteria. This layer absorbs moisture and carries out photosynthesis, synthesizing resources, providing oxygen for the astronauts, and nutrients for the mycelium itself. The innermost layer is the construction and materials that will be in direct contact with humans. This is a massive undertaking. The most critical element is the growth of the fungi. However, the cost required for this plan is extremely high. Building a spacecraft costs $500 million, and each launch costs over $1 million. Our entire research team will need to be transported to the moon, along with all the necessary supplies. Materials and tools must also be sent up. Afterwards, a long series of experiments will follow, and the final outcome remains uncertain. This is only the first step. Even if we manage to successfully build the fungal shelter, this would only solve the exterior issues. We would still have to build the entire base. Starting with living quarters to food and transportation, every aspect requires massive financial and manpower investments. On another planet, establishing a colony is indeed incredibly expensive. Therefore, if costs can be reduced without sacrificing essential survival resources, the feasibility of this plan will greatly improve. This is, of course, a direction that scientists are actively exploring. Someday in the future, perhaps we'll really be able to survive on Mars or the moon thanks to fungi. That's it for this episode. Remember to like and share. Thanks for watching. See you next time. 66 million years ago, an asteroid larger than Mount Everest collided with Earth, plunging into the Gulf of Mexico. This event led to the extinction of over 75% of plant and animal species, including many dinosaur species. It took life more than 4 million years to recover, but the environment was forever changed. Therefore, when scientists discovered another enormous impact crater, they were all stunned. This crater is buried about 1 kilometer beneath the Haivada Glacier on Greenland Island. What's even more shocking is that the crater shows no signs of erosion. This suggests that the asteroid impact may have occurred after humans had already settled on Earth. To confirm that their discovery was indeed an impact crater formed by a collision, researchers used sub-ice radar to study the bedrock under the ice. The radar revealed a distinctive signal pattern with a pronounced uplift in the center. After the asteroid impact, the surface rebounds, much like the splash of water when hit by a stone. Further evidence comes from the dispersal of sediments within the ice layer. Scientists discovered astonishing quartz particles, which can only be produced by extraterrestrial impacts or nuclear explosions. Thus, all the evidence suggests that this is indeed an impact crater, with a diameter of about 31 kilometers, making it one of the 25 largest known impact craters in the world. Although it is smaller than the asteroid that caused the dinosaurs' extinction, the asteroid that formed the Chesapeake Bay crater was also relatively small, while the asteroid that created the Westvac crater would need to be larger, with a diameter exceeding 1.5 kilometers. Scientists still cannot determine the exact age of Westvac, but it is at least relatively young. Currently, it's the only impact crater visible to the naked eye. At least it can be seen where the ice is thin. There is already evidence showing its age is between 100,000 and 12,000 years old, but it could also be over 1 million years old. If the impact occurred when Greenland was covered in ice, that is, for most of the past 2 million years, billions of tons of ice would instantly vaporize, resulting in a surge of fresh water into the world's oceans. It is precisely such an influx that may have occurred around 12,800 years ago, helping to trigger a millennial glacial period known as the Younger Dryas. But the evidence for such a flood remains inconclusive. When an asteroid hits, distant regions would feel the impact. Hurricanes would sweep through the area, and objects up to 100 kilometers away would be flattened. Alright, that concludes this episode. Please remember to like and share. Thanks for watching. See you next time. Cygnus V404 is a black hole less than 8,000 light-years away. Astronomers have discovered that this black hole is wobbling rapidly, and it's dragging the very fabric of the universe. Its companion star is a K-type subgiant, with a mass of about 70% that of the Sun. This star orbits the black hole in 6.5 days. Because the star, relative to the black hole, is moving laterally, matter spirals inward to form an accretion disk around the black hole. When material in the disk gets closer to the black hole, it moves even faster, until it nears the speed of light. When slower material in the surrounding disk rubs against faster-moving material, The friction heats the disk to millions of degrees. This makes the disk extremely bright, especially in the X-ray band. It is precisely this intense X-ray emission that allows us to detect the black hole. The rotating disk produces a powerful magnetic field. This field tears material off the disk and ejects it in a jet along the black hole's rotational axis. A team of astronomers used an array of instruments to perform high-resolution radio imaging of this explosion. They hoped to capture the jets moving away from the black hole, but they found that the inner disk, spiraling inward like a gyroscope, was undergoing rapid precession. In other words, the black hole is dragging the space-time around it. This is an effect predicted by Einstein's general relativity, also known as the Lenz-Thirring effect. This effect was directly measured by NASA's gravity probe. The spacecraft was equipped with a freely spinning gyroscope. When space closer to Earth moves faster than space farther away, the gyroscope's rotation gradually drifts sideways over time, pointing to the material flowing from the star into the disk, keeping it in the same plane as the star's orbit. But when it gets close to the black hole, it gets caught by a space-time tornado, becoming tilted relative to the outer disk. The intense radiation produced by the eruption causes the inner disk to expand, forming a lofty plasma ring. In fact, the Earth precesses once every 26,000 years. Precession refers to the phenomenon where a rotating object, due to the influence of torque, causes its rotational axis to rotate around a central point, and this is due to its axial tilt and the gravitational pull from the moon. But the disk near the black hole undergoes dynamic changes in just a few hours. On one hand, this is an example of the companion star's interaction with the black hole, yet it represents only 1 part in a billion of what is required to produce the observed effect. On the other hand, the frame dragged by the black hole completely avoids torque. The jet swings about 36 degrees before and after ejection, suggesting that the black hole's spin axis must be tilted by about 18 degrees. Supercomputer simulations show that supernovae are chaotic and not perfectly symmetrical, making it very likely in Cygnus V40 for S-super. It is the same with confidence. This might have caused the black hole to shift about 18 degrees, resulting in the imbalance we see today. That concludes this episode. Please remember to like and share. Thanks for watching. See you next time. Asteroid impacts on Earth are a bad thing. They can destroy the entire world. But in reality, comets, meteors, and asteroids frequently come to Earth. They are all very small in size, so they basically do not affect humans. But when a huge asteroid hits Earth, the situation is completely different. As physics formulas show, force equals mass times acceleration. A huge mass inevitably poses a threat to us. But it also must have enough speed to cause destructive impact. If the speed is not fast enough, it can hardly penetrate the atmosphere. So there is no need to worry at all. Research shows an asteroid 10 kilometers long hitting New York City could kill about 2.5 million people. If a huge asteroid hits the ocean, the unvaporized water would cause massive waves, surging in all directions, and could destroy all land in its path. Currently, humans are working hard to prevent asteroid impacts on Earth. Teams like NASA dedicate themselves to monitoring and identifying all satellites, comets, and asteroids near Earth, then predicting if they will hit Earth. Many countries and organizations have done this and conducted simulations of asteroid impacts on Earth. The most direct and obvious option is to launch nuclear bombs at the asteroid to blast it away. But if the asteroid breaks into smaller pieces, equally deadly fragments could still cause widespread destruction on Earth. At the same time, humans cannot accurately predict the timing of an asteroid impact, and cannot even confirm if it will hit. Because of this, people worldwide are exploring all possible solutions, working hard to prepare as best as possible. They are testing experiments to see if a large asteroid can be deflected, preparing option tests for cases where the asteroid is solid, hollow, or composed of one or more materials, adjusting laser power to see if it can be melted, etc. NASA has been simulating and planning. They plan to build spacecraft to intercept asteroids, or use technology to alter asteroid trajectories to avoid collisions. For example, in 2005, they hit a comet called Tempel 1 with a probe, causing a huge explosion, which deflected the comet's orbit, or used planes to carry space probes that land on the asteroid, then melt the rock surface with lasers, forcing gas out from inside the rock to push it off its original orbit. That concludes this episode. Please remember to like and share. Thanks for watching. See you next time. The legendary sea monster is huge and terrifying and hungry, but it is just a myth, right? So, what if this ocean giant really exists? First, we classify the sea monster as a cephalopod, like octopuses, squids, and cuttlefish. Sea monsters are also very intelligent and highly evolved marine creatures. Cephalopods are mollusks, so they have no bones, making fossil formation difficult. This explains why no sea monster remains have been found. But it also brings a troubling possibility. If sea monsters live by scientific laws, they're not immortal, which means there could be more than one. They are reproducing. That is to say, giant squids now inhabit all the world's oceans. So, we shouldn't feel safe yet. Legend has it that sea monsters can be as large as several small islands. Their backs can have a circumference of up to 1,500 meters. It is said that these creatures can drag massive ships underwater with their tentacles. To achieve that, how much force would be required? Archimedes' principle states that the buoyant force on an object in a fluid is equal to the weight of the fluid displaced. If you multiply the ship's total tonnage by the density of seawater and gravity, and then subtract the ship's own weight, the resulting force is exactly the force a sea monster would need to drag your ship under. In simpler terms, sea monsters are extraordinarily strong. If at least one of these creatures lives in the deep ocean, then every sea voyage would be very different. If this deep-sea beast lurks in the Atlantic, it would change the course of history as we know it. If this sea monster were to swallow ships, the Vikings might never have taken to the seas again. Imagine Christopher Columbus and his crew might have perished in those waters. And thus, the New World would never have been discovered. If it had existed from the very beginning, it would have disappeared long before humans ever appeared. Today, we can assume that explorers avoided sea monsters during their voyages, and the creatures did not wreak havoc on the oceans. However, we still can't be certain that these ancient sea monsters are entirely extinct. After all, humans have explored only 5% of the oceans. The deep sea remains an enigma. It might very well be the legendary creature of lore, but it's hard to imagine what it would actually look like if it truly existed. We have already built truly enormous structures in space. Previously, we deployed around 5,000 satellites into low Earth orbit. Some are still operating, while others have long ceased functioning. If we could build an even larger and brighter satellite and send it into low Earth orbit, perhaps we wouldn't need to turn on our lights anymore. The largest satellite placed in low orbit is about the size of a soccer field, similar to the International Space Station. After multiple launches, scientists finally assembled it into one unit. Today, it orbits approximately 400 kilometers above Earth, circling the planet. So, how can we launch an artificial satellite that is 10 times its size and position it at a higher altitude above Earth? On Earth, most low-orbit satellites operate directly above the International Space Station, while some are in geostationary orbits about 35,000 kilometers from Earth. Meanwhile, the moon orbits us at a distance of 380,000 kilometers. But we don't have to place an artificial moon that far away. We only need to position it between Earth and the International Space Station, while making sure it maintains a speed of 27,400 kilometers per hour. Otherwise, it would be pulled back toward Earth. We plan to cover its surface with highly reflective material, so that it can bounce back plenty of sunlight. That way, even if we turn off our lights, people can enjoy bright nights all year round. However, this artificial moon might adversely affect those who rely on moonlight for hunting or nighttime navigation. Of course, you might even need to install blackout curtains in your bedroom, since too much light at night can affect your health, increasing the risk of obesity and heart disease, as well as diabetes and depression. Ground telescopes will struggle to capture deep space images, which might force us to abandon our dreams of the distant cosmos, trapping us on Earth forever. It is said that some aerospace engineers are already researching this concept. They are looking into building structures not just 10 times the size of the International Space Station, but as much as 80 times larger. And its brightness would be 8 times that of the natural moon. It is claimed to save them about 1.2 billion yuan in electricity costs annually. But we still haven't seen any concrete plans or development strategies. Whatever the future holds, we still love our naturally beautiful moon. We can colonize it and use it as a spaceport for future space travel.
So what do you think?
That's all for this episode. Remember to like and share. Thank you for watching. See you in the next episode. As part of the Artemis program, a division of NASA plans to return to the moon by 2024. They will focus on exploring the lunar polar regions, because there might be large amounts of water there. This is a crucial resource. In 1968, NASA announced 5 safe and accessible landing sites for the Apollo missions, because they were aiming for the moon's south pole. So when Artemis lands on the moon, it will be even more challenging. Water will be one of the most valuable resources available to explorers. It can be used for many things. Water is a miraculous shield against radiation. At the moon's south pole, sunlight hits at a low angle. There might be permanent ice deposits there. These ice deposits have existed for billions of years. As early as 1998, NASA's lunar missions already detected a significant increase in hydrogen near the moon's south pole. This suggests that this water has been deposited there. In 2009, NASA sent its Lunar Crater Observation and Sensing Satellite to crash into the moon in search of water. On October 9, 2009, scientists collected samples from the initial impact and found hydrogen, ammonia, and methane, as well as metals like sodium, mercury, and silver. The moon's south pole might offer an abundance of resources for future explorers. According to the latest research from NASA, these deposits are only a few thousand years old. To find a more precise answer, NASA and other organizations are planning a series of missions and experiments to find out if there is enough water for astronauts. The European Space Agency plans to send a lunar lander to the moon's south pole, while China's Chang'e 4 lander and Yutu 2 rover are currently exploring that area. In 2020, South Korea will launch its first lunar mission, called the Korea Pathfinder Lunar Orbiter. NASA has developed an instrument named ShadowCam. It will study craters that are permanently shadowed at the lunar poles. On July 1, 2019, NASA selected 12 new technological innovations to be sent to the moon. They will help study the lunar surface and prepare for astronauts' arrival. As part of the Artemis program, lunar rovers can be tested on site to locate areas with the highest concentrations of water and other useful chemicals. Over the next decade, the moon will become even busier. That's all for this episode. Remember to like and share. Thank you for watching.
See you next time.